In the beginning, God created the heavens and the earth. According to the Bible, God created our universe in 6 days. On the 4th day, God created our sun, our moon, and the other planets of our solar system. Then it says, He made the stars also. Is this true history? Is this how our universe came to be? According to secular scientists, the answer is no. Most secular astronomers believe that the heavenly bodies formed by gradual natural processes over billions of years. They say that this idea is scientifically sound, that it's based on solid scientific principles, that it matches all the evidence. But this isn't true. In the first video of this series, we looked at the planets and moons in our solar system. We looked at the secular model for the solar system's origin, known as the solar nebula model. We discovered that there's lots of evidence against this model. Each of the planets contradicts it in various ways. In fact, the model predicts that many of the planets in our solar system can't exist at all, but they exist nevertheless. Rather than supporting the secular model, our solar system is consistent with the biblical account of creation instead. But what about everything else we see in the heavens? The universe contains 100 to 200 billion galaxies. Each one contains about 100 billion stars on average. Can the secular model explain these objects? No, it can't. In this video, you'll discover how the universe proclaims the glory of its creator as we explore its stars and galaxies. I'm Spike Psarris, your host. In this video, we'll be talking about stars, galaxies, nebulae, and many other things. Before we do that, though, we should talk about what they are. We've all seen stars in the sky, but many people don't know much about them. A star is just a hot ball of gas out in space. Our sun is an example of a star, and it's the one that's closest to us. However, not all stars look like the sun. Stars come in an amazing variety of sizes and colors. We'll talk later about why that's important. Also, not all stars are single like the sun is. Some stars have companions, with both stars orbiting their common center of mass. These are called binary pairs. Other stars are found in multiple star systems, made up of 3, 4, or more stars. In this video, we'll also be discussing galaxies. A galaxy is a large collection of stars, along with some gas and dust. Galaxies range from having just a few million stars to over 1 trillion stars. The galaxy we live in is called the Milky Way. This is an artist's conception of what the Milky Way would look like from the outside. Since we live inside of it, on dark nights we see it as a band stretching across the sky. We estimate it has about 200 billion stars, including our sun. Galaxies also come in a wonderful variety of sizes and shapes. Here are 2 galaxies in some familiar parts of the sky. Close to the Big Dipper, or Plough, is a spiral galaxy known as M81. Spirals like this one can have beautiful, intricate structures. Other galaxies have structures that aren't as well defined. Here's an example that's close to the Crux, or the Southern Cross, where we see a cluster of galaxies, including a massive elliptical galaxy and some other ellipticals and spirals. Along with stars and galaxies, we see lots of other beautiful things in space. In this video, you'll see many photographs of nebulae, large clouds of gas and dust. Some of these are among the most beautiful objects in space. They play an important role in the discussion about where stars came from, as we'll see. Lastly, you'll hear me use the word evolution in this video. This might surprise you, because obviously this video is about astronomy, not biology. Well, as you can see by these textbook covers, secular astronomers often apply the word evolution to planets, stars, galaxies, and even the entire universe. In astronomy, the word is commonly used to describe how these objects supposedly formed and changed over time, all by themselves, with no creator being involved. In this video, I'm going to use the word in the same way. So where did the universe come from? Most evolutionary astronomers believe that the universe formed by itself about 13.7 billion years ago in an event called the Big Bang. Here's a timeline of what they believe. Supposedly, the universe started out as an extremely hot and dense point, which suddenly ballooned in size. Eventually, it expanded to the size it is today. According to this idea, The early universe had nothing in it except gas. Eventually, the gas started to clump together. Within the clumps, there were areas of higher density, and those areas started to contract under the influence of gravity. As the clouds contracted, the gas was compacted and it heated up. Eventually, the gas was squeezing in on itself so tightly that nuclear fusion ignited deep inside. This was the first star. Other stars also began to turn on in the early universe. As stars formed, they gathered into clusters and galaxies. Exactly how this happened is still controversial, but most secular astronomers would agree that stars merged into clusters, clusters merged into galaxies, and galaxies merged to become bigger galaxies. Somewhere between 7 and 9 billion years ago, our own Milky Way galaxy began to form. Then, about 4.6 billion years ago, our Sun formed when a cloud of gas and dust collapsed. The planets of our solar system formed from the same cloud, including the Earth that we live on today. So that's an overview of the secular model. In the previous volume of this series, we saw that this model can't explain how the planets of our solar system formed. In this volume, we're going to step farther back and look at earlier parts of the model. We're going to ask an important question. According to the secular model, should there be stars and galaxies in the universe today? The answer is no, there shouldn't be. Let's talk about why. If the Big Bang model were true, should we see stars in the sky today? The answer to this will probably surprise you, especially because there are frequent announcements about discoveries of star-forming regions in space, like this nebula. We're told that we see lots of places where stars are forming today. Evolutionists like to point to regions like this as support for their model, but that's a logical fallacy, a red herring. Whether or not stars are forming in the universe today, or whether they could form in the universe today, is not the question. The question is this: if the universe formed itself as the Big Bang model says, without a creator being involved, would we see stars today? And the answer is no. Here's why. In the Big Bang model, stars are supposed to have formed from clouds of gas, as gravity squeezed the gas together. But there's a problem here. A cloud of gas in space will not collapse into stars on its own. It's true that gravity pulls the gas molecules together, but gravity is a relatively weak force, and it's much weaker than gas pressure, which forces the gas molecules apart. Here's an illustration I like to use. This is a can of compressed air. When I pull the trigger, it opens a passage from outside the can to inside the can. So what happens when the gas can travel freely? It comes out, because gas always disperses from areas of higher pressure into areas of lower pressure. When I give talks about this, I like to ask the audience, how much gas would you need inside the can to create such a strong gravitational force that when I pull the trigger, gas wouldn't come out of the can? Instead, all the air in the room would get sucked into the can, and we would all asphyxiate and die. People laugh because this idea is ridiculous, but that's the kind of concentration of gas you would need to form stars from a gas cloud in space. You can't maintain a cloud of gas at a higher pressure than its surroundings unless you keep it in a container of some kind. This can is a container, so the gas stays inside without dispersing. But there aren't any containers in space, so there's nothing that prevents gas clouds in space from dissipating. Not only that, there are other things that will prevent a gas cloud from collapsing into stars. As one evolutionist wrote, "We know the cloud wants to collapse under its own weight to make one or more stars. But rotation, as well as turbulent motion within the cloud, work against that fate. So too does the ordinary gas pressure you learned about in high school chemistry class. Galactic magnetic fields also fight collapse. They penetrate the cloud and latch onto any free-roaming charged particles contained therein, restricting the ways in which the cloud will respond to its self-gravity."